have this other one, and again we're going to be told that A, B, C, D, and P, Q, R, S are similar. And again, it takes a while to kind of learn, but when you see the word similar, you need to think all angles or corresponding or matching angles are equal and sides are proportional to each other. All right, again, I'm going to start by picking any two matching sides. I'm just going to go for the one that's on the top. I'm going to start this, and I have to put that over the corresponding or matching side for the other figure, and that's this one. It goes right over there, matching. We're going to set up another fraction over here, and since x is on our bottom, and we want it to be on the bottom of the fraction as well, we're going to use the matching side from the original and put that value up here. We're just, again, they gave us way too many numbers. These problems can look really confusing and intimidating at first just because there's numbers everywhere. They gave you way too much, but just think of it as you have freedom of choice. So that can be a good thing. Again, to solve for proportion, whenever you have two fractions equal to each other, you cross multiply. We need to do 2.4, multiply that by 5, and that's gonna, seems like we end up with 3x on both of these. Okay, so 2.4 times 5, doing that on a calculator, and the answer is going to be 12. We need to get the x by itself. It's multiplying with the 3, so we divide, and 12 divided by 3 means that x is going to equal 4. And again, does it make sense? Our bottom one here would be 4. It's a little bit less than this side here. This one's a little bit less than that side there. It's not a humongously huge number. It matches pretty well. This side is less than that side less than this. Gut check, it seems fine. All right, I hope this helped. This topic is called similar polygons, and basically you need to know what similarity means. Similarity means that two figures have the same shape, but they're not necessarily the same size. It means that their sides are proportional to each other, but the good thing about this is your angles are equal. So this angle here is going to equal this angle here if the two polygons are similar. Similarity itself can be a pretty long topic. What I'm going to do is show you how to solve for x. We have an unknown side here on the second smaller one, so we need to figure out how to get that. The key on that is saying that the sides are proportional. So what you want to do is kind of find out which sides from J, K, L, M, N kind of match or correspond to P, Q, R, S, T. There's a correspondence between these two figures. So I call it matching, but in the math world it's called corresponding sides or corresponding angles. So what we're going to do is we're going to pick any two pairs of sides. I'm gonna for the left-hand figure, I'm going to just pick this one here, NM. So 3, and what is its matching one on the other figure? The matching number on the other figure is 2.4. Again, the math term would be correspond. These two sides correspond to each other. We're going to set up a proportion and choose two other sides to equal each other. And since we need to find what x is going to be on the bottom because this value here came from the bottom. And so we need to find the corresponding or matching side from the original figure, and that would be this guy here. They match. We have a proportion set up, so the way that you solve that is you cross multiply. So we're going to have 2.4 times 6 has to equal the other two sides that have to cross multiply. When we take a calculator and we do 2.4 and we multiply it by 6, we're going to get 14.4, and that's set equal to 3x. We need to get the x by itself. That means we need to undo this multiplication. To undo multiplication, we divide, and when we do 14.4 and we hit divided by 3, we're going to get 4.8. So the measure of that unknown side, the top of this one here, has to be 4.8. And you can kind of gut check that. Does that make sense? Well, in our original figure, this was the biggest side. Our matching one here is 4.8, which is, again, the bigger side. It's bigger than all the other sides in the figure. So at least we figure we're in the ballpark. And it's not horrendously bigger. If we'd gotten like 40.8, that doesn't really make sense. It's way too big of a number. So at least you can kind of gut check it and see if that works out okay. Let's try another.